Now let's solve systems of equations by substitution. Okay, so for example, we have a system of equations. At this moment, we just studied two variables, system equations with two variables, two equations. 2x plus y is equal to 5 and negative 4x plus 6y is equal to 12. All right, so how do we solve it? So the first equation relates x and y. Our strategy is the following. From the first equation, we solve y in terms of x, which means we're going to move 2x to the right side. It becomes y equal to 5 minus 2x. And then, since they are the system, they form the system equation. So this y is the same of the y in the second equation. So we substitute y by 5 minus 2x in the second equation. Sometimes you can label them. This is the first equation, this is the second equation. Okay, so substitute 5 minus 2x for y in the second equation. Then what do we have? We have negative 4x and plus 6. Y is this, so it's a 6 times parenthesis 5 minus 2x is equal to 12. And now you have equation with just single variable. So let's try to solve it. So it's negative 4x plus 30 and minus 12x is equal to 12, right? You just distribute 6 into the parentheses. And then negative 4x, negative 12x is negative 16x. 30, you move to the right, it's a 12 minus 30. So negative 16x is equal to negative 18. So x is negative 18 over negative 16. What is it? We cancel negative 2, we'll get a 9 over 8. So we get x is equal to 9 over 8. Once we know x is non-equal to x is equal to 9 over 8, then we back substitute to the y equal to 5 minus 2x. So y is 5 minus 2 times 9 over 8. So it's a 9 over 4. So cancel 2 with 1 copy of 2 from the denominator. So it's 11 over 4. 5 is 20 over 4. 20 minus 9 is 11. So the solution is the ordered pair. First you copy x, and second you copy y. So this is a solution. Since this solution comes from your complete computation, so this system of equations has just one solution. And this whole process, you see, we do substitution and the back substitution, so that's why it's called the method of substitution. Okay, the method of the substitution. It's not difficult, it's not complex, because so far we only have 2 variables. If later we have 3 variables or 4 variables, this substitution is still simple but will be tedious. It will take more time and steps. All right, so second, let's see, solve system of equations by elimination. By elimination. So what is the elimination? Let's see the example. So we have 2x plus 3y is equal to 1. Negative x plus y is equal to negative 3. So equation 1 and equation 2. So what is the elimination? We have two variables. That make the problem difficult. So we want to eliminate one variable. How do we eliminate? In the textbook, they eliminated x. Now let's try to eliminate y. See how it works. So here you have 3 copies of y. If I can get negative 3 copies of y from the second equation, then we add these two equations. Then the 3y and negative 3y, they will be cancelled. Y will be eliminated. So that's a strategy. So we multiply second equation by negative 3. Remember, I'm going to do the elimination. So here 3, I multiply the other equation by the negative of the coefficient. Here 3, it becomes negative 3. If originally this is a negative 3, then I will multiply the second equation by positive 3. Always opposite sign. Okay, so we multiply equation 2 by negative 3. So negative 3 times negative x, it becomes 3x. Negative 3 times y becomes minus 3y. Negative 3 times negative 3 is 9. Okay, so just term by term multiplication. Negative 3 times this, negative 3 times this, and negative 3 times this. Okay, let's call it equation 3. And then we are going to add equation 1 and equation 3. We add equation 1 and equation 3. So how do we add? 2x plus 3x, 5x. 3y plus negative 3y, that's why we multiply by negative 3. 3y plus negative 3y, nothing, no y. 1 is equal to, so it's the left hand side, you finish. So you copy the equal sign. 1 plus 9 is 10. So 5x is 10, then x is 2. Okay, so you see here, just by the multiplication and addition, we can eliminate y. In this equation, there's no y, so we eliminate y. And then we solve the x by the division. Once we get x equal to 2, you can either select the first equation or the second equation to compute y. For example, because the second equation is simple, it does not have a lot of coefficients, so I'm going to select the second equation. Substitute or plug in 2 for x in equation 2. So you will get negative x is negative 2 plus y is negative 3. So y is negative 1. Okay? So the solution is x, y, 2 and negative 1. This is a elimination because by the first step, we eliminate y. Just cancel them. Here, we also eliminate y, but we do substitution. We replace y by its formula, by its relation with x. So that's the second method, the elimination method. Okay? So from two methods, we know that how do we solve the system equations? We try to reduce the number of variables. If you have two variables, we don't know how to handle them. So we try to reduce the number of variables to one variable. So here, we reduce the number of variables by substitution. Here, we reduce the number of variables by cancellation or elimination. So that's the difference of those two variables, and that's it. Okay, so back to the example we discussed. Remember, last time we discussed that you have a movie theater, you sell the tickets at a regular price, $8, and you have discount for the senior $2, so the tickets for the senior is $6, and X represents the regular tickets, the tickets at the regular price, so 8X. Y represents the number of tickets at price 6, discounted price. And the total revenue, total sale is $3,580. So 8X plus 6Y is $3,580. Remember, this is the quantity, the data from the example we discussed the last time. And we also know that the total ticket sold last time was 525. So we form this system of equations. We try to solve it. So how do we solve it? We can try this elimination method. How? I'm going to multiply. Okay. I'm going to multiply equation 2. Again, you can cancel, you can eliminate X or you can eliminate Y. Either works. For example, now let's eliminate X and we leave Y. If we want to eliminate X, so here's 8. I'm going to multiply second equation by -8. So we'll get negative 8x minus 8y is equal to, well, 525 times 8. 4242. Okay, negative 4,200. Right? So this is the second equation. Let's call the third equation. And then we add equation 1 and equation 3. Equation 1, equation 3. So 8x plus negative 8x cancelled. 6y plus negative 8y becomes negative 2y. So here's you see, this is negative 4,200, and this is positive 3,580. So you add them, it's like this. Okay, so well, we do the subtraction. So it's a 4,200 minus 3,580. So it's 0, 2, 6. Okay, so it's a negative 620. Negative 620. And from here, you divide the two sides by negative 2, you will get y is equal to 310. When you get y equal to 310, you substitute in the second equation. You see, second equation is simple. I don't need to multiply by 6 and divide by 8 later. So that's why I choose the second equation. You substitute back in the second equation, you will get x is what? X is a 525 minus 310. It is 225. 225. 2 what? No, 215. So 2 minus 1. 215, not 225. 215. 215. My bad. All right. So they sold 215 at a regular price. And 310 at a discounted price. At a discounted price. Right? So that's the solution. It's very tiny because I don't have enough space to write it down in one page. Okay. So that's a elimination method, which is multiplied by a proper coefficient so that once we do addition, certain variable will disappear. All right? So those two methods both try to reduce the number of variables from 2 to 1. Now let's see what may happen if we have inconsistent system. Inconsistent system. What is the inconsistent system? No solution, right? Let's see the example. How can we be sure there's no solution? For example, the first equation is 2x plus y is equal to 5, and second equation is 4x plus 2y is equal to 8. All right, so you can use either method. You can either use the elimination or use substitution. And here, let's try to use elimination. Let's try to use elimination. We are multiplying equation 1 by -2. You see, y 2y. If I want to cancel y, here I have to multiply by -2. So it's -2y plus 2y. They are canceled. We get -2 times 2x is -4x. -2 times 1 minus 2y is equal to -2 times 5 is -10. This is equation 3. We add 2 and 3. 1 is used, so we add 2 and 3. We are not always manipulate equation 2. Sometimes we modify equation 1. Okay, so -4x, 4x plus -4x cancelled. 2y plus -2y cancelled. So the left hand side becomes 0. What is right hand side? 8 plus -10 is -2. So we do come up with 0 is equal to -2, which is impossible, right? So this is impossible. This is impossible. It implies your original equation does not, your original system of equations does not have solution. The system of equations has no solution. Then the system is inconsistent. Inconsistent. Okay? If you try to sketch the graph of those two lines, you will see they are really parallel. They have the same slope. They are parallel. Okay, so this is an inconsistent system. Another interesting situation, but not the Euro situation, interesting situation is the dependent situation. Remember, you have infinitely many consistent and dependent. Consistent and dependent. Okay, so let's see what is a consistent and dependent case. Okay, so first we still have 2x plus y is equal to, not this time, here is a 5, here is a 4, which is 4. And second equation is a -6x minus 3y is equal to -12. We'll try to solve this system equations. We call them equation 1 and equation 2. And similarly, we're going to multiply equation 1 by what? So you see y -3y. So we're going to multiply the equation 1 by 3. Then you will get 3y plus -3y. Y is cancelled. Okay, so what we have? 2x times 3, 6x. Y times 3, 3y is equal to 4 times 3, 12. This is equation 3. And then we add equation 2 and equation 3. So -6x plus 6x, 0. -3y plus 3y is 0. So left hand side is 0. Right hand side, -12 plus 12, 0. That's of course correct. That is obviously correct. So when this happens, we will see they are dependent. Two equations are dependent. Actually, you can see that those two equations are equivalent, even though they have the same expression. But if you multiply this equation by -1 for two sides, you will get this the equation 3. So they are equivalent. They do represent the same line with a different formula, but they do represent the same line. So it's always true. This is always true. So it means you have two redundant, two identical, two equivalent equations. And in other words, you can ignore one and just consider the other one. Okay, for example, we consider 2x plus y is equal to 4. And we move 2x to the right side, so y is equal to negative 2x plus 4. And in this case, x can be any real number. X can be any real number. Once you determine x, you will use this formula to determine y. So you will have infinitely many solutions. So the solution set is x and y, such that y is equal to negative 2x plus 4, and x can be any real number. Right? Just because those two equations are equivalent. In our language, we will say they are dependent. Okay, so this is our 3 subparts. Part 1, we introduce the substitution method. Part 2, we introduce the elimination method. And part 3, we gave examples of inconsistent system. And part 4, we gave examples of a consistent but dependent system. So in a consistent but dependent system, you will have infinitely many solutions. Okay, so all these discussions are related, depend on the number of variables. So we only have 2 variables, so it's very short. You see here, we normally just use 3 or 4 lines to compute. If we have more variables, the situation is similar, but the computation will be longer. So, for example, we have systems of 3 equations with 3 variables. Okay, so first let's see what the geometric explanation about each different cases. Remember, in the in the system of 2 equations with 2 variables, we have 2. We have this, see, intersect, this consistent and independent. This is inconsistent, no solution. This is a consistent but dependent case. Those 2 equations are equivalent, so they are consistent, independent, inconsistent, consistent but dependent. That's a 2 equations, 2 variables. The situation will be a little bit complex if we talk about 3 equations, 3 variables. So it's a following. In 3 equations, so we will have x, y, z. X and y, they form plane. X, Y, Z space. space, in XYZ space, a linear equation. Remember, we talk about just linear equation. A linear equation represents, here, a linear equation represents a line, and in this case, a linear equation represents a plane. So, I don't know if I can sketch it properly or not. If you have a three plane, you possibly can have for example, I'm trying to trust my drawing skill. Well, you trust my drawing skill. So if you have three planes, you have one horizontal, the other one is slant, and the other one is vertical. This way, you see, you have a horizontal plane, and a slant plane, and a vertical plane. Then they will intersect at a single point. This is consistent. Again, consistent means their solution. Consistent. Actually, they are independent. Consistent, independent, but we don't have independent name. Just consistent. This is one case. And the other case, one solution. The other case, we have the following thing. It's like I'm going to use pages to represent. Assume I have three pieces of paper, white paper. One page is placed, this is a one plane, it's placed horizontally. The other plane is rotated this way, and the third plane is rotated even further. It's like you open book, you open several pages with different degree angles. You see, they will intersect at the bending place. So if I can sketch it better, it will be like this. You have a horizontal one, and you have a vertical one. And you have another, you see, all three planes will intersect at a line. So every point from this common line will provide a solution. So this is consistent. The system equations has solution, but they're infinitely solutions. They're infinitely solutions. And also, there's a case that all three equations are equivalent. They just represent one plane. So for example, you will have x equal to 0, 2x equal to 0, and 3x equal to 0. Even though they are all linear equations, they have different formula, but they are all equivalent. Then the corresponding plane will be the same plane, x equal to 0. X equal to 0 is a YZ plane, but whatever. So this also contains infinitely many solutions. But the solution form a plane. Here the solution form a line. That's the difference. So we have consistent, one solution. Consistent, infinitely many solutions. But in this case, we will have the infinite many solutions form a line, or infinite many solutions form a plane. This is consistent. And inconsistent inconsistent also has two cases. It's like this, I guess this way. Oh, no, let me try to sketch it. You see, it's like a tent. You form a tent. You get one plane, you get the other plane, you get a floor. And these two, like the left plane, left wall intersect with the base at this line. The left wall and the right wall, they intersect at the roof. And the right wall and the floor, they intersect at the right line. But they do not share a common point. So this is inconsistent. You see, it becomes already complex. This is the case. And another case will be like this. You have three parallel planes. Three parallel planes. Each pair has no intersection. Here, you see, this left wall and the floor, they still intersect. Ground, they still intersect. And the left wall, right wall, they also intersect. Each two, they have solutions, but three of them have no solution. But here, even two of them have no solutions. So this is also inconsistent. So you see here, once we raise the number variable from 2 to 3, you already have such complex situations. With 2 variables, we only have 3 graphs, but with 3 variables, we already have 5 graphs. And with 4 variables, you will expect even more cases. But again, this is consistent. They have solutions. This is inconsistent. They have no solutions. All right? Okay, now let's see examples. So we have a system of 3 equations with 3 variables. X plus y minus z is equal to -1, and 4x minus 3y plus 2z is equal to 16, and 2x minus 2y and minus 3z is equal to 5. And we want to use elimination method to solve it. In the previous case, you have 2 variables. You can eliminate x or eliminate y. In the 3 variable case, you can eliminate x, y, or z. But once you fix one, you're going to do that. Just eliminate that variable. You will not mix them. The first step, you eliminate x, and second step, you eliminate y. That's not allowed. You will be consistent. You eliminate z, then you will always eliminate z. Right? So for example, here, let's try to eliminate x. So we label 1, 2, and 3. If I just consider equation 1 and equation 2, I want to eliminate x. Here's 4x, so I'm going to multiply the equation 1 by -4x. Multiply equation 1 by -4. By -4, not -4x, by -4. So it becomes -4x minus 4y and plus 4z is equal to 4. -1 times -4 is 4. Let's call this equation 4. And then we're going to add 2 and 4. Equation 2 and equation 4. Be careful, there's so many equations, just be careful. 4x, -4x, cancelled. -3y, -4y is -7y. 2z, 4z, 6z is equal to 16, 4, 20. Let's call it equation 5. Okay? So by this elimination process, we killed x. And then I'm going to ignore the middle equation and just consider first and third equation. Just consider first and third equation. Okay, so I still eliminate x. Once you choose x, you will eliminate it for all the equations. So here's x, here's 2x. So I'm going to multiply equation 1 by -2. So it becomes -2x minus 2y and plus 2z is equal to 2. Let's call it 6, equation 6. And then we're going to add equation 3 and 6. Add 3 and 6. 2x, -2x cancel. -2y, -2y, -4y. -3z, minus 3z plus 2z is minus z. 5 plus 2, 7. That's equation 7. All right, so what do we have? So far, we have first equation and second equation added to the equation 4. Third equation added to equation 6. So you see here, equation 5 and equation 7. Equation 5 and equation 7, they are from the previous elimination process. So it is a system of 2 variables and 2 equations. 2 variables and 2 equations. So we are going to continue to solve this system equations. How do we solve it? Clearly, we're going to multiply. This is 5 and 7. So you see here, it's easy to eliminate z. So we multiply 7, equation 7 by 6, So we'll get negative 24y minus 6z is equal to 42. That's quite 8. And then we are going to add 5 and 8. Add 5 and 8. So negative 7y add negative 24y is negative 31y. 6z add negative plus negative 6z cancelled. 20, 42 is 62, right? And from here you get y is negative 2. Right? You divide the two sides by negative 31, you will get y is negative 2. When y is negative 2, check here, y is negative 2, negative 4 times negative 2 is 8. 8 minus z is 7, so z is 1. Okay? So y is negative 2, z is 1. These two parts go back to equation 1. You can select either of them, but I just choose the simple one, the one with a smaller variable coefficient, my bad. So x plus y minus z is equal to negative 1. So x is 2. X is 2. Right? You just try to solve it. You move this minus 3, move to the right, plus 3. Negative 1 plus 3 is 2. So the solution is remember it's ordered pair, not a pair. This is not pair, the triple. So it's 2, negative 2, and 1. The solution is 2, negative 2, and 1. It means x is 2, y is negative 2, and z is equal to 1. Right? So you see, what is the elimination method in the system of 3 equations with 3 variables? We use one elimination process to change this system to a simpler system. The new system has 2 equations and 2 variables. And then we based on the discussed process to either you use elimination or you use substitution to find the solution of this new system of equations. and then go back to the original problem and solve it. So you actually have two steps. First step, reduce the number of variables from 3 to 2. And second step, from the number 2 to number 1. You see, this is the equation with just single variable. All right, we always try to reduce the number of variables. Okay, so this one has a unique solution. It is a consistent system. If we can have some powerful computer graphical tools, we can see the three planes actually intersect at a single point. Okay, now let's see an inconsistent system. Inconsistent system in the current situation with the three variables, three equations. Let's see what we have. We have 2x plus y minus z is equal to negative 2. X plus 2y minus z is equal to negative 9. X minus 4y plus z is equal to 1. Okay, so we try to solve this system of equations. We name them equation 1, 2, and 3. All right, so we try to eliminate variables. You see, possibly this z is easy to manipulate, right? Well, it's easy to eliminate for z. So we multiply the equation 1. I want to eliminate z. I want to change this minus sign to be plus by negative 1. So we get a negative 2x minus y and plus z is equal to 2. This is equation 4. And we are going to add equation 4 with equation 2. Add 2 and 4. Add 2 and 4, let's see. X plus negative 2x, negative x. 2y plus negative y plus y. Negative z plus z cancelled. Negative 9 plus 2, negative 7. That's equation 5. Okay, so now we cancel 1z. And I will also want to cancel this z. This z is easy, we just directly add. So we add equation 1 and equation 3. We get 2x plus x, 3x. Y plus negative 4y minus 3y. Negative z plus z cancelled. Negative 2 plus 1, negative 1. This is equation 6. All right? So we put these two equations, these two new equations together. They only contain two variables. So we have negative x plus y is equal to negative 7. 3x minus 3y is equal to negative 1. This is equation 5, equation 6. Good. Now let's continue the elimination. I'm going to multiply equation 5 by what? If I want to cancel x, I will multiply it by 3. By 3, we will get a negative 3x plus 3y is equal to negative 21. Let's call it equation 7. And then we add equation 6 and equation 7. Negative 3x plus 3x, 0. 3y plus negative 3y, 0. So left hand side becomes 0. Right hand side, negative 21 plus negative 1, negative 22. Well, we have some strange conclusion. So this is impossible. This is wrong. What can we say? What can we get from this wrong conclusion? It means the original system has no solution. It is inconsistent. Okay, no solution, inconsistent. That's it. So after eliminate one variables, we do find two equations with two variables, and then we continue the elimination. We get some strange condition. So it is inconsistent. Seven. Let's see another one. It's, you see here, we try to give all possibilities. We try to give the discussions about all possibilities. So here we have consistent, we have inconsistent, and we want to discuss a consistent but dependent situation. Consistent dependent means you have infinitely many solutions. So let's try. We solve it. We have x minus 2y minus 2z is equal to what? 8. 2x minus 3y and plus z is equal to what? 23. And 4x minus 5y plus 5z is equal to 53. Try to solve it. Okay. Well, again, I'm trying to eliminate x. We try to eliminate x. Oh. 1, 2, and 3. The equation 1, 2, 3. Multiply 1 by negative 2. By negative 2, I'm trying to cancel x. So I will get a negative 2x plus 4y and plus 2z is equal to negative 16. This is equation 4. And add 2 and 4. Add 2 and 4. X, negative 2x cancelled. Negative 3y plus y is just a y. Z plus 2z, 3z. 23 plus negative 16. What is it? 7. Right, it's a 7. So this is equation 5. And then we multiply 1 by equation 1 by negative 4. I'm trying to cancel the x. So it's a negative 4x plus 8y and plus 4z. Remember this multiply the equation by negative 4, so the negative becomes positive. And negative 32. This is equation 6. And we are going to add equation 3 and equation 6. Equation 6. So 4x plus negative 4x cancelled. Negative 5y plus 3y, 8y is a 3y. 5z plus 4z, 9z. 53 plus negative 32, what is it? It's 23, right? 21, not 23. I have to be careful about my computation. Okay. So let's see what we get. We are going to put equation 5 and equation 7 together. So it's y plus 3z is 7, and 3y plus 9z is 21. 3y plus 9z is 21. Okay, so, well, let's see. Well, this is a 5. This is a 5, this is 7. I'm going to multiply the equation 5 by what? By negative 3. I'm trying to cancel y. So we will get a negative 3y minus 9z is equal to negative 21. Let's call it equation 8. And we add equation 7 and 8. Negative 3y cancel. Negative 9z, 9z cancel. Left hand side 0. Negative 21, 21. Always correct. Always correct means this equation is redundant. It's additional, extra, not important. Right? So what we can have, we can just eliminate this equation. Just say so we have. Oh, well, of course you can eliminate 5. 7 and 5, they are actually equivalent. You can just drop one of them. So you will have first equation. This is equation 1, and this equation 5. And last one, nothing. You can put 0 equal to 0. But it's not useful. It's not useful. Okay, and then from here, from y plus 3z equal to 7, we can get y is equal to negative 3z plus 7. That's our substitution. And then you're going to substitute this relation back to equation 1. You will get x minus 2 times negative 3z plus 7 and minus z equal to 8. And then from here you solve it. You will get x is equal to, what is it? It's equal to negative 5z and plus 22. Or just try to solve it. Okay, that's negative 5z plus 22. So what is the solution? The solution is, let me copy it. X can be negative 5z plus 22. Y can be negative 3z plus 7. Z can be any real number. All right, once you determine z, you will determine x and y. And this is actually the situation, this situation. It depends on just a single z. It will be a line. Okay, so see here, the consistent and dependent situation is very long. We just reduce from 3 to 1, 2 from 2 to 1. And when you get 1, you get 0 equal to 0. It means you just drop 1 equations. Okay, once you get 0 equal to 0, you drop one of those 2 new equations you get. From 3 variables to 2 variables, you will get 2 variable equations. If you get 0 equal to 0, you drop one of them. If you have 0 equal to 0, you will drop one of them. Right? Yeah. Okay. So that's all the material discussed in this section 12.1. The first part, we just try to set up vocabulary and necessary concepts. And in the second part, we really try to solve the equations of a linear equation, the system of linear equations, Okay, so do the exercise. Make sure you know how to do those computations. If you have any questions, let me know. Now let me show you all the pages. This is page 1, 2, 3, 4, and 5. Okay, thank you. Well done.